All right, Mike, we're good. It's all you. Sorry.
Cool. Well, first off, thanks for joining us. As Vic already said, we're happy to have you all here. Um, we always like talking about Python stuff here at Pi District, formerly Django District. I'm going to be talking about something that is related to Python and is written in Python, but is not specifically for Python. So for any of you that are new to Python and maybe more familiar with other languages, it's a good chance that what I talk about will benefit you even outside of your Python world. Also, feel free to brag about this to all of your friends that are not using Python. I think it's a wonderful conversation for us to have, and I'm excited to talk to you about pre-commit. So before we talk about the pre-commit hooks, I want to talk about static code analysis to set a little bit of baseline here. For those of you that aren't aware, static code analysis is basically the idea of running some sort of automated assessment of your code without actually executing the code. It's more just like looking at the content of your code. Some common uses for, or common methods of static code analysis would be linting, which is the idea of finding bugs or syntax errors in your code. You can also identify security vulnerabilities, like if you have a dependency that has a vulnerability, or what if you have like a SQL injection bug in your code? It's not really a bug, it's more just like a security no-no. You can also use static code analysis to do things like generate metrics for your code, like code coverage is one, although that requires running your tests. But also, you know, how much code do you have, how much technical debt do you have, what is your code complexity, all that kind of stuff. So how do we do static code analysis? Well, the two general ways of doing it are by installing a plugin into your IDE so that, you know, every time you like save your file you're working on, it runs a bunch of checks and lets you know what's good or what's bad, or auto fixes things for you. Or maybe there's like a drop-down menu or something to execute these things. Or we do static code analysis in the continuous integration pipeline. So this is, you know, you push your code to version control, it starts a deployment to dev, but before it gets to dev, it runs some amount of checks and puts the report somewhere, whether that's in your Jenkins logs, or if you have SonarQube, there might be a nice dashboard to view all this stuff. The idea being it's running these checks after you push your code to version control, but before it gets to dev. So there's problems with both of these approaches. The problems with the IDE approaches is mostly which IDEs are we using? Like, there's a lot of IDEs out there. Are we supporting all IDEs? That sounds like an endless endeavor because once you get your VS Code IDE all configured right for your team, then a new developer joins and says, hey, I use Vim. And you go, oh man, now I got to figure out how to do all this stuff for Vim. And then someone comes and they say, I use Eclipse. And you say, who uses Eclipse for Python? But you know, it's an endless endeavor to try to figure out how many IDEs do we need to support, especially for a team that's growing. Additionally, if you're working on any sort of open source projects, it'll be tricky to enforce any IDE sort of linting because you can't force someone that you don't know on the other side of the earth to follow your rules of behavior. It involves a lot of trust. Ultimately leaves the door open to people doing what they're going to do, and it doesn't strongly enforce any sort of standards. Now, CI-based analysis can enforce strong standards because there's one script or one job or one task or whatever that runs in your CI pipeline that has one configuration that everyone is bound to. The problem with CI-based analysis, though, it's a little late in the feedback loop to find out that you had something that was bad. You might have gone through the entire peer review process and gotten, you know, your whole team involved in reviewing something, only to find out that it's borked and you have to make a bunch of changes and go through the review process all over again. Some of the version control tools out there, like GitHub, for example, try to mitigate this by putting some of those feedback loops inside the PR process, the peer review process, pull request process, which is, it's better because now you have a slightly earlier feedback loop, but it's still one of those things where you're sharing it with your whole team before you've done some of this automated cleanup. Also, at this stage, it would be irresponsible for the tool to automatically fix any of the things it finds, because you never want something to automatically fix something that doesn't go past human eyes. If you have a tool that removes unused imports, well, what if you have import star in your init.py that the script says, oh, this isn't being used by anything, and it goes ahead and removes it? That would be bad if that got pushed into master. The linter just wasn't smart enough to know that it actually was being used strategically. So you usually want these things to go through some human eyes, and having the automation process late in the pipeline basically means you can't do that automation. Or you can't responsibly, at least. Some of you might have seen the news recently that GitHub released a new service called super-linter, which is super cool. I actually planned this talk before a super-linter was announced, but it was convenient for me to plug this into what I wanted to discuss. I have a link right here that you guys can't click right now, but I will share the slides to this channel and to the meetup, so that if you guys do want to go visit some of these pages, I have links in here to help you along. Super-linter is basically GitHub's approach to linting in the pipeline in the PR process, and it has like hooks to support pretty much every language that is popular right now, and that is neat, right? So here's a little screenshot from their blog post where they announced a new tool, where they say that it provides an earlier feedback loop. The results cannot be ignored by a rogue developer that just doesn't want to abide by your policies. And you can even have one repo that has lots of different file formats. So you could have your JavaScript and your Python and your Markdown files and your JSON and your YAML, and it all gets linted via one process. There's also a way to run this locally, but it's not meant to be run locally. I'm hoping that this is something they improve on in the future. But for now, it's really meant to be plugged into the GitHub pull request process. So some cons of this super-linter as of today, where things will hopefully change in the near future. The super-linter picks one program to do the linting for each programming language. So for Python, all you get is pylint. And pylint's great. It has a lot of really good stuff to help you identify problems in your code, but it's not a holistic, fully functioning ecosystem of linting that we could have for Python. Notably, pylint doesn't auto-fix stuff. It just complains that you're doing things badly. There are a bunch of tools out there that will actually not only complain that you're doing things badly, but actually fix it for you. For example, hey, you're using tabs, but the Python norms say you should be using 4 spaces. Let me just go ahead and replace all the tabs with 4 spaces for you. Pylint will complain about it, but it won't fix it for you. But we can use other tools that can. Unfortunately, super-linter only supports pylint right now. I'm pretty sure that'll change eventually in the future as this super-linter ecosystem gets better. So super-linter's neat. There's a couple of cons. I wanted to throw out a hypothetical there. Not guaranteeing that anything satisfies all this, but just a little thought exercise. Wouldn't it be cool if we had something like super-linter, but it wasn't locked into the GitHub ecosystem? It was really meant to be used anywhere. You could use it on cloud version control. You could use it in your DoD's top secret closed environment that doesn't have any internet access. What if we had a tool that could move the feedback loop even further to the left? So before you even push your code to version control, we want to do our linting possibly like using a Git hook. What if we had a tool that could automatically apply changes, which I just talked about on the last tab, and was open by design? So it's really easy for you to add new hooks or new checks that didn't exist yet. You weren't stuck with what the tool gave you when you downloaded it on day one. Well, I think you'll be happy to know that that tool does exist, and I'm going to spend a little bit of time talking about it. It is called pre-commit, and I am pretty enthusiastic about it. I learned about it probably a little over a year ago, and I've been using it ever since, and I'm very happy with it. And I want to share my happiness with you. Having said that, I do want to articulate that my main point I'm trying to get across in this talk is that you all should be thinking about using static code analysis tools somewhere in your pipeline, presumably earlier rather than later. In no way am I saying that it's pre-commit or nothing. Super-linter is fine. IDE tools are fine. Having some sort of standard process for your team to have common coding standards is good. I'm just going to talk about why I think pre-commit is the best option out there. At pre-commit's website, they make this statement right here, which is pre-commit is a framework for managing and maintaining multi-language pre-commit hooks. I added the asterisk there. I'll tell you why in a second. This doesn't say anything about static code analysis. This doesn't say anything about linting or security vulnerabilities. It really just says pre-commit hooks. But the community that's developed around pre-commit has really ramped up the support for being able to do more or less static code analysis in pretty much every popular language out there right now. So what are pre-commit hooks? Before I get too far along with the tool, pre-commit is a tool that's written in Python. Pre-commit hooks are a thing that existed before the pre-commit tool. Whenever you initialize a Git repo using the get init function, Git creates a .git folder in the path that you're working in. And in that folder, there's a bunch of stuff. And one of the things in there is another folder called hooks. And in hooks, there's a whole bunch of files that end in .sample. These are all sample hooks in Git's pre-organized hook system that you can use if you want to. The one that's most popular out there is the pre-commit hook. And this is a script. Could be a bash script, could be a Python script, whatever kind of executable you want that'll execute in the environment on the operating system you're using. It is a script that will run right after you type the git commit command on your computer, and before it actually saves the commit in your Git history, you know, with a hash and everything. This pre-commit script, if it fails, it can throw an error that basically aborts the commit. So the commit doesn't go through, and instead you have to presumably change something so that it passes the next time the script runs, at which point the commit will go through. It's also worth noting the pre-commit tool, the Python one, actually supports 10 types of hooks. It doesn't only support pre-commit. That's just what most of us use it for. But if you want to do a pre-merge commit or a post-update, you can, any of those other types of commits in here, most of them are supported by pre-commit as well. So there are the hooks to do that. Most of my time today, actually all of my time today, though, we'll be talking mostly about pre-commit. All right, so right here, I am re-implementing everything that super-linter does in pre-commit the Python tool. So first I pip install pre-commit, that downloads and installs it into my environment. Then I create a file called .precommitconfig.yaml, and it looks like this, where you define an array of repos, where each repo is a link to that repo, which hash or tag you want to use, and then a list of hooks. So you'll see here, I'm actually pulling down pylint from pylint's actual Git repo, and pylint actually has another file in their repo that tells pre-commit how to wire up. So this repo is pre-commit friendly, and I can just reference a hook that they define here using this hook ID. I would show more links, but I don't want to slow things down too much. Just go to the pre-commit website if you want to learn more. It's not that complicated to wire all these things up. The point being, this basically is my way of registering that, hey, I want to, when I run git commit command, to run pylint as part of that process. Then when I run this pre-commit install command, and this actually installs a hook into the pre-commit hooks script that knows how to load this YAML file. I can continue to change the YAML file as much as I want. You only have to do this once. for each repo. All right, so the pre-commit install command, like I said, created a pre-commit hook. So once I run this command, I can say, hey, show me the first 20 lines of the pre-commit command. And as you can see, it's a Python shell script. And there's not a whole lot going on here that needs to make sense to you. I guess you could point out, oh, hey, here's the config file it looks at. There's another several hundred lines of code below this that are basically a bunch of Python code that loads this YAML file, ensures it's a valid YAML file, parses it, does a whole bunch of crazy stuff with it. More detail on what we need to get into at this point. All I wanted to articulate here was the pre-commit library is doing a lot for us to make our lives easy. All we need to do is define which hooks we want to use, run pre-commit install, and we're done. From here on out, anytime I run git commit in this repo, it'll run these hooks that I defined. All right, so I wrote my most proud Python code ever. It's this script that asks me what my name is, and then it prints out the name I typed in, and then there's a bunch of gibberish afterwards. It's a long line. Pretty awesome code. Also, there's an if statement that is always true. That's fun. Why not? The point of this is I was writing some code that I'm expecting to actually throw some errors when we run pylint. So I ran pylint on this, and I ran pylint by running a git commit command, which ran the pylint git commit hook. And it basically threw out a bunch of errors. It says bad indentation. I was using tabs instead of spaces. One of my lines is too long. The limit should be 80 characters because anything more than 80 would just be nuts, right? Let's see, I had trailing new lines at the end of that file down here. Well, you can't really tell, but trust me, there's a new line down here at the end of the file that doesn't have any purpose. Let's get rid of that. And oh, look, I imported sys and I imported OS, but we aren't even using them. Like that's an unused import. That's silly. So pylint basically spit out a bunch of output saying, hey, this was a failure. And what that means is that the git commit actually failed. So the files that I had staged to commit are still staged to commit. There's nothing in my git history. I need to fix these things before pylint will let the commit succeed. That's kind of annoying though, because now I have to go find all these things and fix them myself. So what if we actually put in some hooks that do auto fixing for us? That's pretty cool. So above pylint, I have two other hooks. One of them is black. So a lot of you probably have heard of black, which is a, I guess, an opinionated PEP8 linter that will format your code the way that this tool thinks Python code should be formatted. For example, it'll enforce 4 spaces instead of tabs. It has an opinionated belief that double quotes are better than single quotes. That sort of stuff to make your code look like proper Python code. This Z imports tag here is an import sorter. So basically, if your imports are not alphabetically sorted, it'll sort them alphabetically for you. But it'll also remove any unused imports for you. That's cool. And I kept the pylint one here. This is the first one we started with, but it's actually going to run third. And what I'll show you is that these guys are going to fix so much that this one isn't going to have much to complain about because all those problems have already been fixed. So if I run this again, it's a lot going on here, so hang with me. I ran the git commit command, same thing I did last time. And the first thing that runs is black. That was the first thing in that list of 3 YAML configs. And it failed, but it said, hey, it failed and I reformatted one file for you. That's cool. Then Z imports runs and it failed too. And it said, hey, files are modified by this hook. That's cool. Then pylint ran and it failed too. And it said, hey, there's one thing here that is failing. So it used to be the last time we ran this, there were, what is that, 7 things? And now there's 1. But why did this 1 not get auto-fixed by the things above? Well, the 1 is not really easy to auto-fix. I have a variable that should have 3 characters, but it only has 1. Pylint says that all variables in Python should have 3 characters. Well, there's no really good way to auto-fix making a variable any longer. Like, what should I change it to? XYZ? XXX? Like, I don't know. There's no, like, standard no frills way of fixing that. So that has to be left to us to manually resolve. but I hope you can appreciate that the first two hooks in here actually fixed a bunch of stuff for us, so we don't have to. These changes are actually now staged in your Git workflow, so that all you have to do is git add those changes and git commit, and next time those errors won't pop up again. So the effort for you has been greatly reduced, because not only are we testing for errors, we're fixing them for you too. So this is a git diff that shows what happened with those auto fixes. You can see it remove the imports. It replaced the single quotes with double quotes, which is Black's opinionated styling. It replaced the tabs right here with four spaces. And let's see, it took this really long line and it actually broke it down into multiple lines to make it not past the 80 character limit. Pretty cool, right? Okie doke. So that's pre-commit in a nutshell with a couple of simple examples. I did want to dig in a little bit deeper to how broad or how flexible this tool is. So in quotes, a quick feature summary. Pre-commit is made to be extended. They have a community with lots of hooks that you can use, and it's just as easy as adding them to the YAML file to use them. They also make it very easy to make your own hooks. So if you have an idea for a hook that doesn't exist out there, it's not hard for you to make it on your own and plug it in. This is different from super-linter, which is limited to pylint right now, and that's take it or leave it. That's all you get. It supports several execution platforms. By execution platforms, I mean these are the languages that pre-commit will run the hook in. So it can run a Docker container hook. It can run a Node hook. It can run a Rust hook. Obviously, it's a Python tool. It can run Python hooks too. Basically, all of these are executed by making a virtual environment, more or less, for each of these languages in a like .cache folder somewhere in your home directory. So it basically knows how to prepare the environment for all of these. There are hooks for lots of other languages. They just don't run in that language. So you can run a Java linter via a shell script, for example, or via a Docker container, even though there's not an execution environment for Java. Also, we can lint for more than just programming languages. We can lint markdown files. We can lint JSON. We can lint, I don't know, I'm drawing blanks here. We can link Terraform and Ansible scripts. So it's not just like proper programming languages. We can lint basically any sort of file. There are linters out there to do spell checkers on just regular TXT files, if that's what you want. So normally pre-commit only runs against files that have been changed in the commit that you're submitting. But if you want, you can run pre-commit against all files in your repo. That's really handy if you're adding pre-commit to an existing repo. So you can basically set your baseline of like, hey, we're adding pre-commit to our norms for this project, and I can run this command to run against all files that exist to date. And then moving forward, it'll only run pre-commit on the changes in your git commit. This is also useful if you want to plug in pre-commit to your CI pipeline, so that if someone is trying to be a rogue developer and ignore the rules or the norms that you're setting, it'll throw an error once it gets to the CI pipeline to say, hey, someone didn't lint their code for some reason. Like, let's go do that before this code gets too far. I don't have time to dig into all the overrides and tweaking things you can do, but it's a very flexible language that allows you to specify exactly which hooks should be run for which files. It allows a lot of ways to override the defaults. It's cool. Check out the website. I have a link for it later to learn more about how broad and how flexible this tool is. Some cons, I want to be honest, there are some cons. Pre-commit does not support every language natively. I mentioned Java, for example. But generally, Shell and Docker are sufficient enough to do what you need to do to test your programs. Also, we all use Python, so who cares? It does require the developer to install pre-commit locally in their local development environment. So if the developer doesn't know to do that or forgets to do that, the hooks will not be run until you run that little command to inject it into your Git repo. So really this involves having team norms and expectations, onboarding stuff to make sure that everyone's set up properly. But like I said, you can still put the command into the CI pipeline so that if someone is, for on purpose or not on purpose, not abiding by the rules of our pre-commit ecosystem, we can still alert our pipeline fail to draw attention to hey, someone's not doing the linting on their pre-commit phase. I want to do a quick aside about the creator and maintainer of pre-commit, Anthony. This really isn't so much about Anthony, it's about PyCon, really. I've actually never talked to Anthony. I've never met Anthony. So this is not like a marketing pitch for him. But at PyCon, I guess it would have been last year, you know how like when well, for those of you that have been to PyCon or other conferences, they have a big giant lunchroom where everyone sits down. And, maybe you have a friend or two that you found to sit next to, but a lot of times you're just sitting by yourself. So there's a bunch of random people at the table with you. You have no idea who they are. And you always go through these like standard conversations of, hey, where are you from? How long are you here for? Are you a web guy or a data guy? That kind of thing. Well, my Sophie, who many of you know from this meetup, Sophie was at PyCon last year, and she sat down at a table and was having those standard conversations. And the guy sitting next to her was like, "Yeah, I maintain this cool tool called pre-commit." And Sophie was like shell shock or so it's just a celebrity moment of like, "Whoa! Like we totally use pre-commit. We love that. That's so cool." Anyway, I thought it was a fun story. You never know who you're going to bump into when you go to PyCon or any conference. So I encourage you to do that. And that's one thing we lose by doing all these virtual things. We don't get those little bump ins with minor celebrities that, are really these impactful things that you never forget. I also wonder how many people bump into Guido every year and have no idea who he is. Anyway, back on topic. What hooks are available for Python? There are lots and lots of hooks. And I wish I had time to talk about what all these hooks do, but I don't have time to do that. So I'm kind of running through this quickly. But there are hooks for all the types of linters that are popular out there. There are also hooks to do things that are not normally part of a normal linting thing, like sorting and arranging your requirements files, or ensuring that your Jinja templates actually are valid Jinja templates, or parsing your docstrings to make sure they're well formatted, or even like ensuring that the code inside of a docstring is valid Python code. Those are all things that exist out there. Also, if you're worried about security, there are hooks to run the tools Bandit or Safety, which are security-focused libraries out there for Python. There's also a lot of hooks out there that aren't specific to Python, but are certainly useful to all of us, such as hooks that make sure that you don't have any AWS private keys or credentials accidentally in your code, which I'm sure you've all heard of, like the people that have lost how many millions of dollars because they oopsie committed a key to their master branch and then someone hacked into their Amazon account. Stuff like checking for merge conflicts. Those little carrots that show up in your file whenever you have a merge conflict, and what if you forgot to remove one of them and clean it up? Like, you should fail your commit because there's a unresolved merge conflict. Or checking for file permissions. What if your IDE saves everything as writable? That doesn't make any sense. Your file shouldn't all be writable. You can enforce that as a commit hook. Okay, so then there's a question, what about my friends that write their code in a different language? Well, that's a good question. As I already mentioned, there's lots of support for lots of different languages out there, whether they're like configuration languages like Ansible, Chef, Puppet, CloudFormation, or actual languages like Perl or Bash, or I'd never even heard of Nim. Maybe you guys have, but there's linters for Nim. I don't even know what that is. There's also like a lot of legacy support. So, if you're doing things that have been around for a while that are, I think we'd all agree are probably like less popular these days, although C++ always shows up in the Stack Overflow list of popular languages, but it's not a trending modern language, right? But there's still linters for that too, or even like bash files, right? And there's even linters for Mac admin files. So if you're like an operations person that's maintaining Mac laptops, there might be some tools in there that make your life easier. Anyway, lots and lots of hooks. There's a link right here that links to the hooks website. It's precommithooks.com/hooks. It's like there's a big list of them. There's actually, I think I did the math, 348. There's 348 hooks out there that are tracked. There's probably a lot more out there that haven't even been submitted to the landing page. I also want to clarify, pre-commit isn't the only option. As I said earlier, there's also GitHub super-linter, for example. It's perfectly valid to use your IDE or CI pipeline to do this sort of analysis as well. I just think pre-commit's really valuable because it's early in the process in a way that still can be a norm for all of your team. There's also a couple of libraries that are very similar to pre-commit. Left hook is one that is, I believe it's Ruby language. They do support Python. You have to actually install a separate Python wrapper library via pip that knows how to piggyback onto left hook. I have no experience with this. I'd love to see how it compares. And then there's also Husky and LintStage. I don't know if any of you guys are familiar with the JavaScript ecosystem. These basically do the same thing as pre-commit, where they wire into your Git hooks, but it's really specifically for JavaScript. I was actually using Husky when I found out about pre-commit because I was annoyed that we had all this awesome hooking auto checks for our JavaScript code, but our Python code wasn't getting the same love. And that's when I found out that we could use pre-commit to lint both our JavaScript code and our Python code in the same library. Like they're in the same Git repo, sorry. And we can lint both of them at the same time, which is pretty cool. Whereas Husky basically like locked out the Git hooks for only JavaScript. So that was a lot, and I appreciate you hanging along for all that. But the biggest point I want to get across here, so in conclusion, is that I believe the pre-commit hook phase is a valuable place for all of us to be doing some testing and auto-fixing of our code. It creates a team-wide standard, and it's a fast feedback loop. I hope that the pre-commit tool or the other options out there appeals to all of you, especially if you aren't familiar with doing this in your normal working process. If any of you work with a larger team, this can really help you create consistency so that you all have sane styles and expectations for what's going into your code. That's all I have. Any questions?
How do you balance like performance that, so I'm concerned about the performance overhead of running a suite of linters every time I commit. I tend to be a very nervous committer and then rebaser. So I find it kind of more intrusive in my workflow. Have you found any ways to parallelize this, or does pre-commit do that for you? Because at least for the the ones that don't actually modify your code, I could see that being useful.
Yeah, I haven't looked into the parallelizing, but I'm assuming it doesn't because this shell output's very procedural. Having said that, on a competent computer, it usually runs in a second or two. It's pretty snappy. Having said that, like my client computers are slugs, and sometimes it takes 30 seconds for the hooks to run. But those are also computers where it takes 12 minutes to do a pip install. So that's not a normal environment. For those of us that are working on reasonable hardware, I don't think you'll find it to be an impediment unless your hooks are doing really complicated things like running the entire test suite, which you totally can do, but that'll definitely slow you down. But most of them are pretty snappy. And the reason why is because they're really only executing against the files that have changed. It doesn't run it against your entire Git repo. So unless you're committing like lots of files every commit, it's really a fairly limited analysis that it needs to do.
Awesome, thanks.
All right, cool. Well, it doesn't sound like I have any other questions. I'm going to share the slides to the channel after I stop sharing. So feel free to poke in there if you want to look at any of the links I provided. And if you have any questions, again, feel free to reach out to me either during or after this event.